All right, so I don't know if you remember, but we signed in yesterday. In case you forgot, you probably have the link from Google Classroom, but this is the website you gotta go into, and you had to log in using your first name, last name, middle name at PHS. That was your username, and your password was Paris. And when you go in, I'm a teacher, so I have all this, but you won't. You would only have these two. Okay, and what you want to do when you want to go into your lesson is you click on this one. But again, I'm a teacher, so there's no assignments here. But yesterday I gave you one assignment for, I think it was chapter, was it 15.1? I think so. And then you're going to see another assignment, okay, for the next section. And these are all the evaluate questions that you already have access to, but I'm just assigning it to you so nobody can ever tell me anything about anything. So anyhow, you click on the Interactive Student Edition in order to go to your interactive version. I'm just so excited because now you can save all your stuff. You go into Unit 6, and then we're done with Chapter 14, right? And so now we're going to go into Chapter 15. As you can see, this is a very lengthy section, and so your next test is probably not going to be next week, but the week after, like on a Wednesday. So not next week, but the week after. So I just want you to think about the fact that we have to finish one section per day, and just keep that in mind. We already did 15.1, so you're going to click on 15.2. And when you do that, a new page pops up like this. So today we're going to learn about isosceles and equilateral triangles. The lesson is very simple, but obviously it is confusing when I am not here. So what I'm going to do is I'm going to give you homework for this section, and then of course tonight you have homework again for 15.3. But when you come to class, I want you to feel free to ask me questions from both sections, 15.2 and 3. I want everybody to be at the boards because that's the only way you're going to learn. That's the only way you're going to get individual help from Miss Choi. Okay, this video is just a video. You can try your best to learn from it, but I know you learn better when I'm standing next to you. All right, so essential question, what are the special relationships among angles, blah, blah, blah. Okay. So, I know you already know this, but the textbook thinks you forgot. So what is an isosceles triangle? It looks like this, and you can tell, okay? So in case you don't get this, let me draw the triangle again. An isosceles triangle means these two sides have the same length, okay? And these two sides, by the way, they are called legs. That's why they have that here, right? Okay. And then you know what? This angle right here, this is called the vertex angle. Hey, it's right here. I'm just drawing this for you again because sometimes you just look at this picture and you don't get it. So I'm trying to explain it to you again. And of course, by definition, an isosceles triangle has, the same length. This side and this side, they measure the same. And guess what? These angles down here, this one and this one, those are called what? They are called base angles. Oh, where is it? Oh, look, the textbook already has it, okay? So nothing new. We're just trying to remind you what an isosceles triangle is, okay? What's the leg, vertex angle, base angles? Base angles, okay? This is the base, and the red line is the base, and then the blue dots, those two angles will be the base angles. Okay, so now that we know what an isosceles triangle, they're telling you to look at this, okay? And you have a triangle, and you have A, B, C, and it says the measure of angle A is what? This angle here is 15 degrees. And then measure of angle B and C is what? They say this is 82.5 degrees, and that is also 82.5 degrees. This makes sense because when you add this plus that together, you'll get 180. Remember the triangle sum theorem we learned yesterday? We ripped off the three angles of the triangle and we put them together like that, right? Okay. So triangle 2, same thing. This time it has a really, really fat top and a very skinny bottom. We're talking about triangle 2 right now. And so this is 100 degrees here, but measure of angle B and C is what? only 40 degrees. This is 40 and this is 40 degrees. Ah, okay. So these are isosceles triangles, it says. So what kind of conjecture can you make after looking at this? Da-dun, da-dun. Well, I already told you, but the base angles are congruent. Check, and that's correct. All right. So then, this is the lesson. The lesson is, what is the isosceles triangle theorem and the converse? Another thing that you have to learn today is, what is the equilateral triangle theorem and its converse? Those are the two things, okay? So anyhow, let's take a look. The isosceles triangle theorem basically states that if you have an isosceles triangle, right? Basically, if this and this, if they measure the same, because we talked about this is an isosceles triangle, so these two measure the same. Then the isosceles triangle theorem states that the two base angles over here, they measure the same. So you just see a random triangle and you don't know what the heck is going on, okay? But then you measure this and you measure that, and oh, wow, they actually measure the same. Then you can conclude that this angle here, the two base angles, and that angle, they're going to be the same. And that is what an isosceles triangle theorem states. Okay? And of course, they make you prove this. And is this going to be on the test? Most likely, yes. So let's learn this, okay? What's given to you? That this side and this side measure the same. Now you gotta prove that these two angles measure the same. Okay, we already know this is true because that's the isosceles triangle theorem. Okay, we already know this as a fact, but somebody else found out about this by actually proving. So we're going to pretend we didn't know that this was a fact, and we're going to try and prove it. Okay, so BA and CA measure the same. That's given to us. You always start with the given. Angle A is congruent to angle A. Why? Because they're exactly the same angle, duh. So what should we select? Reflexive property. I don't know if you remember this from last year, Math 1 second semester, but when you say that angle A is angle A, or AB is AB, it's called a reflexive property. It's kind of like looking at yourself in the mirror and saying, I look like me. All right, so CA is congruent to BA, and it says it's given to us. Yes, because, we said they measure the same. And then, so these two triangles are congruent to each other because of what? The SAS triangle congruence theorem. Oh, wait a minute. If you are lost because of the SAS all of a sudden, you gotta go back to last year's second semester because you learned this, okay? So the reason why we call this an SAS triangle congruence theorem is because we just proved that one side measure the same, one angle measure the same, and the other side measure the same. So the S stands for side, A stands for angle, and S stands for side. So SAS triangle. When we have a side, an angle, and a side that measure the same, then the two triangles are congruent to each other. Okay? And to just help you remember, we also had SSS, we also had ASA, and we also had AAS, triangle congruence theorem. That basically means if three sides measure the same, the two triangles are congruent to each other. If an angle, side, and angle measure the same, the two triangles are congruent to each other. If you have an angle, and then a side that measure the same, then you have a congruent triangle. Okay? So this was just review. So then, CPCTC basically means corresponding parts of congruent triangles are congruent. Okay? What that means is, if you have two triangles, then if we know that these two triangles are congruent, then this one and this one should measure the same. This one and this one should measure the same. Like corresponding parts, right, are congruent because these two triangles are exactly the same. That's what that means. So then obviously the last thing that I have to put here is this one, because you always end with whatever it is they tell you to prove. And so if you check, you'll find out that everything is correct. So again, you keep going down. And now we talk about the converse of the isosceles triangle theorem. And so then it is exactly that. So now what they're trying to say is, we have a triangle. We don't know what kind of triangle this is, but all we know is that these two angles measure the same. Oh, is that so? If we know that we have a triangle and we have two base angles that measure the same, then we can safely say that these two sides measure the same and therefore this is an isosceles triangle. And that will be the converse of the isosceles triangle theorem. You notice how it goes backwards? When we were just talking about the isosceles triangle theorem, we were saying these two sides measure the same. If so, then the two base angles measure the same. We talked about that, right? But now, all of a sudden, we add the word converse, and now, all of a sudden, it's backwards. They're like, oh, we only have two angles that we know measure the same inside a triangle. Oh, okay, in that case, then we know that this is an isosceles triangle, and these two lines, these two legs measure the same. Okay? Simple stuff. Okay, and you have to prove this. And as you can see, I already practiced this ASA. We talked about this earlier. Watch the video. And the next section is going to talk about equilateral triangles. And of course, you learned this in elementary school, but here's how we remind you. An equilateral triangle has three congruent sides, okay? An equiangular triangle has three congruent angles, okay? That means three angles measure the same, three sides measure the same. Here's a picture of it. It shows that three sides, they measure the same. You can see they measure the same because of this red tick mark. It shows that this line over here, this line over here, that line over here, they all measure the same. So you can go ahead and, oh, I already scrolled it all the way down, but you can go ahead and just scroll it down to see the proof. And you can just learn it on your own, obviously. And then, of course, then they have to talk to you about the converse of the equilateral triangle theorem. This time, what they're basically saying is that if you have a triangle and three angles measure the same, then ta-da! The three sides measure the same, thereby it becomes an equilateral triangle. Okay, so very simple stuff. Let's see. If three angles are the same, prove how all three sides are going to be the same. So go ahead and take the steps all the way down and prove it. And watch the video. So then here comes the solving part. Okay. And you can work on this on your own, but I'm just going to go ahead and show you the your turn question. And then after this, we're done for the lesson. Very easy, as you can tell. It says find the angle measure. You know what I noticed? This is a triangle, and I noticed the tick marks right here and there. That means that this line over here and this line over here measure the same. Okay, so then if two legs measure the same, what kind of triangle is this? Yes, it's an isosceles triangle. I know this because of the isosceles triangle theorem. And according to that theorem, what does it say? When these two sides measure the same, what two angles measure the same? Yep, this angle and that angle measure the same. So then this question says, what is the measure of angle P? Oh, the measure of angle P is this one right here, Q, which is 3x plus 12. But alas, we have an x. So we got to try and calculate that, right? So in yesterday's lesson, we learned about the triangle sum theorem, and we actually ripped off a triangle to prove that when we add all three angles in a triangle, what is it? Okay, angles add up to be 180 degrees, okay? So what that means is we're going to go 3x plus 12 plus 3x plus 12 plus 5x plus 2, and it's going to equal what? 180. So see, again, if you were lost yesterday, you have to go back and catch up because everything builds upon each other. So here's 3x plus 12 for the Q plus 3x plus 12 for the P plus 5x plus 2 for the R. And that's supposed to equal what? 180. Ooh, I feel a little bit out of space over here, but oh well. Let's combine like terms. 3x, 3x, 5x. 3, 6, 11. So that would be 11x. And now let's combine these. 12 plus 12 plus 2. That's 12, 24, 26, right? So plus 26, and that equals 180. I'm just copying that. Now we gotta subtract 26 from both sides. That gives me 11x, that's 0, equals 10 minus 6 is 4, 7 minus 2 is 5, 1. Okay, so now I gotta divide both sides by 11, right? So let me rewrite this because sometimes people get confused. I have to divide both sides by 11, and so that would give me x is equal to 14. But is my answer 14? No, 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 no. Because look at the question. It says, find the angle measure. And what angle are we looking for? Measure of angle P. So what was P? Because of the isosceles triangle theorem, we know that measure of angle P is what? 3x plus 12. So 3x plus 12. That is the measure of angle P. And instead of x, I had to put in 14. So there you go. 3x plus 12. So that's 3 times 14 plus 12. 3 times 14 is 42 plus 12. And that gives me 54 degrees. All of a sudden, I'm scared because I'm thinking if you guys all have the same homework question, I basically did your homework for you. I'm hoping that your digital version gives you a different question. But anyhow, therefore, your answer is 54. And of course, always check your answer. Okay? And of course, I'm correct. If I'm not, then we'll be in big trouble, right? All right. So there you go. You can go ahead and work on the next question on your own. And of course, ooh, more difficult with fractions, huh? So hopefully you'll be able to solve it. If not, you know that Miss Choi is not too far away. This one, you gotta use the equilateral triangle theorem or its converse, okay? So happy learning. Email me, or when you see me in person tomorrow, I'll help you. Just get to the boards, okay? Happy learning. Goodbye.